Hello everyone and welcome to Thinking with Mathematical Models 3.2. Today's learning target, I'm going to be able to tell the difference between the inverse or linear relationships and then write equations for either. So to review from the end of 3.1, we talked about that with our equations for inverse variation that k means constant, okay, the number that's not going to change. And two ways to look at that is x times y equals k, similar to length times width equals area. Or we can take y equals k divided by x. In this situation that we used with length and width, that would mean width equals area divided by length. Okay, so k is constant. So if we see an equation like this, it's going to make a graph somewhat like this, descending at a curve. So if we see a graph like this, we can probably begin to believe that it's going to come with an equation similar to this. Now, the equation that we've been working with early in the year and earlier in this book is y equals mx plus b. When you have that, that's going to be a straight line. So if you have straight lines, your equation format is going to be this way. Curved line, it's going to be more in the y equals k divided by x format. 3.2 ACEs, we're going to do 4 through 7, 22 through 27, 29, and 30 for our ACEs. And 3.2, talking distance, speed, and time. I want you to do parts A and B for this. I'm not going to read all of this to you, but you can stop the video or just open the book and read it. But we want to know that two non-zero variables, our x and y, are related by an inverse variation if y equals k over x or x times y equals k, just like we were talking about before. It says where k is a constant other than 0. Questions to think about: how does the value of one variable change as the value of the other changes when we're talking inverse variations, okay? If one is going up, what's happening to the other variable, okay? And then how was that pattern of change shown in a table of data or on a graph? And we just talked about that on the last screen when I was doing the intro to this, what the graph would look like. And then what equation shows how the two variables are related? Now we talked about that you're going to have an equation in this type of format, so it needs to be able to fit the y equals k over x format. So part A, inverse variation occurs in many situations. You have probably thought about how the length of a trip depends on speed. Well, Mr. Cordova lives in Detroit, Michigan. He often travels to Baltimore, Maryland to visit his grandfather. The trip is about 500 miles each way. It says here are Mr. Cordova's notes for his trips to Baltimore in this past year. So he has different dates here, the way he traveled, and what may have happened, and then how much time it took him to travel. What they want you to do is make up a table, and I've already kind of set one up here. It says travel time in hours, so you're going to take what you have from this table and plug it in here. And then you need to calculate your average speed, or miles per hour, okay? 500 miles, these are your hours. Be able to come up with what the average speed was after you've plugged in your travel times from this table. Part 2, then plot the data on a graph, draw a line or curve to model the data, and describe the change in average speed as travel time increases. So as it takes longer to get there, what's happening to our speed? 3, write an equation for the relationship between time t and speed s, and then determine whether this relationship between distance and time is an inverse variation or not, and be able to explain why. Part B, we have the Cordova family planning a trip of 300 miles from Mackinac Island in the Upper Peninsula of Michigan. And Mr. Cordova does some calculations to see how the travel time will change if the family drives at different average speeds. So average speed of 30 miles an hour, 40, 50, 60, and 70, this is how much time it will take him. Again, we want to describe the change in travel time as the average speed increases. So as this speed increases, what's happening to time here? And what equation relates travel time t to average speed s? How's that pattern relating travel time to average speed shown in a graph? So again, we need to graph this data. And is this relationship between time and speed an inverse variation, and how do you know? Part C, if you have a chance, C is kind of fun. Suppose Mr. Cordova decides to aim for an average speed of 50 miles an hour for his trip to Mackinac. Make a table and graph of that. Show times from when the family leaves home to when they reach their destination. Okay, remember he's going 300 miles at 50 miles an hour, so we want to see that every hour in our table and on our graph. Describe the pattern of change in distance as time passes. Explain how that pattern is shown by values in your table and points on your graph, and then write another equation relating distance traveled d to time t. Now, we need to determine, as we've gone through this, is this an inverse variation or is this a linear relationship? So hopefully after going through A and B and then on to C, you will be able to determine that difference. Get aces for 3.2, 4 through 7, 22 through 27, 29, and 30. Let me know where your stuck points are when we're in class, and I'll be happy to help get you unstuck.